Hello, myself Vijay Srigaonkar, Assistant Professor of Mathematics, Government First Grade College, Ancona. So we have the classes on Raabes test in infinite series. The test says that sigma un be a series of positive terms and limit n into un by un plus 1 minus u1 as n tends to infinity is equals to L, then sigma un is convergent if L greater than 1. Sigma un is divergent if L less than 1, and the test fails when L is equals to 1. We'll see the proof for this statement. We shall compare sigma un with the sigma vn, which is equals to sigma 1 by n raised to p is a p series which is convergent for p greater than 1 and is divergent for p less than or equals to 1. We'll have the case 1 when L greater than 1. Let p be a number such that L greater than p and where p is greater than 1. Then sigma vn is equals to sigma 1 by n raised to p is convergent, as we know that for a p series where p is greater than 1. By comparison test 4, sigma un is convergent if u of n plus 1 divided by un is less than or equals to vn plus 1 divided by vn for all n. If un plus 1 by un is less than or equals to, that is, we have substituted the values of un plus 1 and a un. So we'll have as n raised to p divided by n plus 1 whole raised to p, and simplify this, we'll have as 1 by 1 plus 1 by n whole raised to p for all n. Taking the reciprocal of this term as un by un plus 1, which is greater than or equals to 1 plus 1 by n whole raised to p for all n. By binomial expansion, we know that 1 plus h whole raised to n is equals to 1 plus nh plus n into n minus 1 by 2 factorial into a square plus so on the term. We'll name this expression as equation 1. In this expression, we'll substitute in place of n by p and h by 1 by n. So we'll have un by un plus 1 is greater than or equals to 1 plus p into 1 by n plus p into p minus 1 by 2 factorial into 1 by n whole square plus rest of the terms. Now replace this 1 to the left hand side. We'll have as un by un plus 1 minus 1, which is greater than or equals to p into 1 by n plus p into p minus 1 by 2 factorial into 1 by n whole square plus so on the terms. Again, take 1 by n as a common term outside and the rest of the terms as p plus p into p minus 1 by 2 factorial into 1 by n plus so on the terms. Again, take n this to the left hand side. So we'll have as n into un by un plus 1 minus 1, which is greater than or equals to p plus p into p minus 1 by 2 factorial into 1 by n plus so on the terms. Now apply this term as limit n tends to infinity on both the sides. So after applying the limit as n tends to infinity, we'll have the right hand side as p, where 1 by n tends to 0, 1 by n square tends to 0 as n tends to infinity. So finally we'll have L greater than or equals to p, but p itself is greater than 1 and we know that it is a convergent. Hence it implies that sigma un is convergent if L greater than 1. Now we'll see the case 2 when L less than 1. Let p be a number such that L less than p less than 1. Then sigma vn is equals to sigma 1 by n raised to p is divergent if p less than 1. And by comparison test 4, sigma un is divergent provided un plus 1 by un is greater than or equals to vn plus 1 by vn for all n. Again, as we have done in a case 1, the same procedure applies here. Un plus 1 by un is greater than or equals to n raised to p by n plus 1 whole raised to p. Again, by simplification, we'll have this term, and taking the reciprocal of this term as un by un plus 1 is less than or equals to 1 plus 1 by n whole raised to p for all n. Apply the binomial expansion. We write it as un by un plus 1 is less than or equals to 1 plus p into 1 by n plus p into p minus 1 by 2 factorial into 1 by n whole square plus so on the term. Again, take 1 to the right hand side. We have as un by un plus 1 minus 1 is less than or equals to p into 1 by n plus p into p minus 1 by 2 factorial into 1 by n whole square plus so on the terms. Again, apply limit on both the side. We'll have the right hand side is left with only p, that is, which is less than or equals to p. That is, if L less than or equals to p, but p itself is a divergent for less than 1, which implies that sigma un is divergent if L is less than 1. Now we'll move for the case 3 when L is equals to 1. That is, if limit n into un by un plus 1 minus 1 as n tends to infinity is equals to 1, then the Raabes test fails. So while simplifying the convergency test is, we first notice that Raabes test is normally applied when d elements ratio test fails. So what is the d elements ratio test fails means? Limit un plus 1 by un as n tends to infinity is equals to 1, then apply Raabes test for the convergence. So we'll have the simple example to test the convergence of the given series. So we'll have the series as 1, 5, 9, so on, 4n minus 3 whole divided by 3, 7, 11, 4n minus 1. Here nth term we write as this and un plus 1th term as this. Taking the ratios as un plus 1 by un and simplifying the whole term, we'll have as 4n plus 1 divided by 4n plus 3. And apply limit on both the side and we'll simplify this and we'll have the value as a 1, which implies that the d elements ratio test fails here. Therefore, we apply Raabes test. What is the Raabes test? That is, limit n into un by un plus 1 minus 1 as n tends to infinity is equals to limit n into, we'll substitute the values of un and a un plus 1 here, minus 1, and simplify whole the thing, we'll have as 1 by 2, which is less than 1, which implies that sigma un is divergent. So I think you are clear with the Raabes test and we'll meet in the next class. Thank you.